করেন ডক্টর সাইদুজ্জামান।
দুইটা হাতে লাগতো
তো আপনি এটা একটু ঠিক করে দিতে বলবো, দেখেন
বা না ওখানে বসে করা যায়, বসে করা যাবে,
একটু ওখানে বসে নিয়ে যাবে।
সরি ফর দ্যাট।
Leave the projector. I'm just going to take my wallet out from under it.
My name is Dr. A.K.M. Saiduzzaman Pinganj. Present tonight, the long-awaited beginning of a Ben Canada activity, or a whole galaxy of stars from the environmental science and environmental engineering professions. I would like to take advantage of this opportunity to present some of my thoughts about the environmental challenges Bangladesh is faced with and possible adoption and use of Canadian best practices to address many of these issues. I would now like to give you an overview of what I'm going to talk about for the next few minutes. My first point concerns how I understand the environment. What is an environment to me? Then I will go on to highlight what I see as the main global environmental challenges. Next, I will focus on environmental challenges in Bangladesh, and then we'll consider Canadian best practices. Finally, I'm going to make some concluding remarks. To me, environment is just three major media, environmental media: surface waters, soil, and groundwater, also known as the subsurface and the atmosphere. It is imperative that we understand our environment in sufficient detail so that accurate assessments can be made about the environmental behavior and effects of chemicals that we use. Chemicals released into the environment do not respect the boundaries between air, water, and soil any more than they respect political boundaries. And what is environmental engineering? Let's pay attention to every single word of the definition given by American Society of Civil Engineering and published in 1977. Environmental engineering is manifest by sound engineering thought and practice in the solution of problems of environmental sanitation, notably in the provision of safe, palatable, and ample public water supplies, the proper disposal of or recycle of wastewater and solid waste, the adequate drainage of urban and rural areas for proper sanitation, and the control of water, soil, and atmospheric pollution, and the social and environmental impact of these solutions. Furthermore, it is concerned with engineering problems in the field of public health, such as control of arthropod-borne diseases, the elimination of industrial health hazards, and the provision of adequate sanitation in urban, rural, and recreational areas, and the effects of technological advances on the environment. So this was published in 1977. I think that this definition is very important. Total water resources on the earth amount to 1,386 million cubic kilometers. Only 2.5%, however, that is 35 million cubic kilometers, is fresh water. The balance of 97.5% is the mineralized waters of the world's oceans, salt lakes, and saline groundwater resources. One would think that these reserves of fresh water would be quite sufficient at about 4.43 million cubic meter per head of world population. But the great majority of this fresh water is practically useless. Approximately 70% is bound up in glaciers, About 30% is below ground, and only 0.006% is available in the world's rivers. The situation is complicated by the fact that even this volume of fresh water is not spread equally over the earth. Nowadays, about 60% of land is arid and semi-arid, and in consequence, many countries are completely or partly deprived of fresh water. Of course, there are other problems. I just wanted to limit myself to worldwide water problems. Now let's take a look at the environmental challenges in Bangladesh. The right to life demands three basic things: fresh food, fresh water, and fresh air. We can no longer claim that we have any of these three. All three environmental media seem to be heavily polluted. The contamination of surface and groundwaters are with domestic and industrial waste has already led in a number of cases to such a state that they can only formally be considered natural, but as a matter of fact, they are diluted city wastewater, surface water, chemical oxygen demand values reported to be on average 178 milligram per liter. And groundwater has as high as CUD value as 15 milligram per liter. In all likelihood, water supply and sewerage systems are all poorly designed, operated, and maintained. No or poorly damaged stormwater management, flood control, arsenic in the subsurface as well as in the surface waters. Concentration range of arsenate of 500 to 1600 ppb is typical of groundwater in Bangladesh. The Bangladeshi arsenic standard is 50 ppb, 50 microgram per liter. I would like you all to think about the significance of the figure here. It is 5 times the maximum allowable concentration of arsenic in drinking water in Canada. Air pollution in Bangladesh has reached unthinkable levels. The heavy metals, cadmium, lead, and mercury are common air pollutants being emitted mainly as a result of various industrial activities. And of course, there is noise pollution. I would like to put the situation into some kind of perspective by highlighting Canadian best practices. I think we need to find ways to employ established technologies if we are to seriously address our environmental problems in Bangladesh. The COD of surface water normally ranges from 5 to 20 milligram per liter in Canadian rivers, not 178. For the surveyed surface water supplies, average treated water dissolved organic carbon ranges from 3.2 to 3.4 milligram per liter in summer and 2.8 to 3.5 milligram per liter in winter. In Ontario, which is Canada's most populous province, 28 stations were examined and rated using the water quality indices. 4% of stations were found to have poor water quality, 14% had marginal, 36% had fair, 39% had good, and 7% had excellent. The Don is the only river classified as having poor water quality in Ontario. Let's look at the effluent quality standards in Canada. Carbonaceous biochemical oxygen demand, CBOD, has to be on average less than or equal to 25 milligram per liter. Suspended solids must be less than or equal to 25 milligram per liter. Total residual chlorine TRC has to be on average less than or equal to 0.02 milligram per liter. Unionized ammonia expressed as nitrogen at 15 degrees centigrade plus minus 1 degree centigrade has to be 1.25 milligram per liter. I don't have access to similar data, published by Dhaka Water and Storage Authority, Dhaka Wasa. No data. In Canada, arsenic can be reduced to levels below the guideline of 10 ppb. In both large and smaller municipal plants, arsenic can also be removed by residential scale drinking water treatment devices to levels below 10 ppb. Engineering and environmental practices are very strictly regulated in Canada. It is an offense to practice professional engineering without a license or certificate of authorization, as the case may be, with fines up to $25,000 if found guilty for the first offense. One would be seriously upset by the fact that even the most advanced degrees in engineering and or environmental sciences do not make one a qualified person to practice engineering and environmental science. You can teach engineering or environmental science at the universities, environmental science or even medicine at the universities, but be not permitted to practice engineering or engage yourself in environmental practices unless you are a qualified person as defined by the governments and regulatory agencies. A qualified person is a licensed professional engineer with proper expertise, or a licensed geoscientist with proper expertise. If you are incorporating, registering a business name in Ontario, and you have and the corporation name or business name will have the word engineering or engineers in it, you have to ask for a letter of consent from the Association of Professional Engineers of Ontario first. I think it is challenging, but very good indeed. I operate two companies. One is civil construction and environmental engineering, and the other is Save Our Environment. Engineering disciplines in which I currently practice include building engineering, structural engineering, civil engineering, environmental engineering, and water resources engineering. I would just like to finish with the following concluding remarks. Whichever way you look at it, the underlying picture is clear. Environmental issues in Bangladesh are not unique. It is, many countries are with us, similar conditions. We need to start with the provision of safe, palatable, and ample public water supplies. That's why we need to start. The proper disposal of or recycle of wastewater and solid waste, and the control of water, soil, and atmospheric pollution, including noise as an atmospheric pollutant. I am of the opinion that no environmental action alone will ever succeed if we don't build proper centralized water supply and sewerage systems, including storm sewers first. So we need to address water first. The most practical municipal scale technologies for the removal of arsenic from drinking water include ion exchange, coagulation filtration, lime softening, activated alumina, reverse osmosis, and manganese green sand filtration. The US EPA has also identified electrodialysis reversal as the best available technology. We can and we should make use of North American best practices while manufacturing equipment and materials locally and involving local labor. We are not rich enough to buy cheap things, and we are not guinea pigs in their research into experimental techniques and statistics and speeches and meetings. We need to institute environmental awareness program ASAP, organizing and educating the general public about the importance of our environment's vulnerability, understanding our environment's vulnerability and protecting it. Now let's go out and create opportunities for protecting our motherland. I am reachable at 647-294-8243 or email me at saiduz.zaman at cceengineering.ca or saidus.zaman@saveourenvironment.ca. Thank you very much for your patience.